Welcome to solverfy.
Question 30 is an acid-base question regarding the preparation of a buffer and the modification of that buffer in order to achieve a particular pH. Typically, when working with buffer solutions, we are going to use the Henderson-Hasselbalch equation in order to solve for pH. This question is in reference to a buffer that was prepared by adding 50 milliliters of 0.050 molar sodium bicarbonate and 10.7 milliliters of 0.1 molar sodium hydroxide. So there is no buffer solution with just sodium bicarbonate. When we add the sodium hydroxide, the sodium bicarbonate will behave as an acid and turn into carbonate. Therefore, the base is carbonate and the acid is sodium bicarbonate. So when we set up our Henderson-Hasselbalch equation, pH will be equal to pKa, or the negative log of the Ka value of the acid. We identified the acid as being sodium bicarbonate. Going to the appendix, we see that the second Ka value for carbonic acid, which corresponds to bicarbonate, is 4.7 times 10 to the negative 11. So, Henderson-Hasselbalch equation, pH equals pKa plus the log of, you can either have the base concentration over the acid concentration or the moles of base over the moles of acid. I'm going to use moles. So, we added 50.0 milliliters of 0.5 molar sodium bicarbonate and 10.7 milliliters of 0.1 molar sodium hydroxide. Every mole of sodium hydroxide we add will convert 1 mole of sodium bicarbonate into carbonate. So the moles of weak base formed, carbonate, will be equal to the moles of strong base added. So the moles of carbonate will be equal to the volume of sodium hydroxide, 10 milliliters or 0.0107 liters, multiplied by its concentration, 0.1 molar. The moles of sodium bicarbonate, the acid, will be equal to the moles that we start with. Moles can be calculated just as we did up here by taking the volume, 50 milliliters or 0.05 liters, multiplied by the concentration, 0.05 molar. This is the moles of the acid, sodium bicarbonate, that we have before adding the sodium hydroxide. When we add the sodium hydroxide, the moles of sodium bicarbonate will decrease by the number of moles of strong base added, and the moles of strong base added will be calculated just as we did up here in the numerator. Then what's left is our calculation. So when we calculate, taking the negative log of this value and the log of this ratio, and we sum them up, we get 10.20 as our pH. So that's just part A. Part B is actually the more challenging part of this question. How many grams of HCl must be added to 25 milliliters of this buffer to achieve a pH change of 0.07 units? Well, first we need to identify, is this pH change going to be an increase in pH or a decrease in pH? We're adding a strong acid, HCl, and the strong acid will result in a decrease in pH. Adding a base to a solution increases pH. Adding an acid decreases pH. So we are going to decrease the pH from 10.27 by 0.07 units. This then gives us a new pH of 10.13. So going back to the Henderson-Hasselbalch equation, we have a target pH of 10.13 that will be equal to pKa, the negative log of the Ka value for the weak acid in the buffer, sodium bicarbonate, plus the log of, we'll do the same thing as we did before, moles of base over moles of acid. Well, we are starting with 0.010 times 0.1 moles of weak base before we add the HCl in the entire volume. But we're not trying to change the pH of the entire volume. We're trying to change the pH of just a fraction of that volume. What fraction are we trying to change? Well, we are trying to change 25 milliliters of the total 60.7, the 50 milliliters plus the 10.7. So this will be the fraction of the total moles that are found in the 25 milliliter solution that we are trying to change the pH of. This still is before adding the HCl. When we add the HCl, some of these moles of carbonate, the weak base, will be consumed, and they will be consumed to the same amount of the moles of the HCl added. We want to calculate the grams of HCl, so I put that as X, where the moles of HCl will be equal to the grams HCl divided by the molar mass HCl, 36.46. So this will be the moles of HCl added, which will decrease the moles of base we start with. Then in the denominator, we will have moles of the acid. We are starting with 50 milliliters at 0.5 molar, so that's how many moles of the acid we had before adding the NaOH. When we added the NaOH, it decreased by 0.0107 times 0.1, as we established up here. And that would be the moles that are present in the entire volume, but we're trying to change the pH of just a fraction of that volume, the 25 divided by the 60.7. This is now the moles of the weak acid, sodium bicarbonate, that we have before adding the strong acid and converting some of the weak base into the weak acid. Once we add the HCl, we will increase the moles of weak acid we have by the moles of strong acid we add. So instead of subtracting off X over the molar mass of HCl, we're going to add on X over the molar mass of HCl. Now we have, yes, a huge equation, but one equation and one unknown for which we can calculate X. If we go ahead and figure out the negative log of 4.7 times 10 to the negative 11 and subtract that from both sides, we'll get negative 0.1979. That will then be equal to, well actually, yeah, the log of this entire ratio up here. So all of these numbers will give us 0.000407, and then the reciprocal of 36.46 is 0.0274x. Same thing, figure out what all of this is. That's this number here. And then the reciprocal of 36.46, but it's the log of that whole thing. So then what we have to do is take the anti-log of both sides, 10 to the negative 0.1979 is 0.6340. That then will be equal to this entire ratio without the log. If we then multiply both sides of the equation by this denominator, then we get this is equal to just the numerator up here. Then we need to collect our like terms. We'll put all the x terms left hand side and all the non-x terms on the right hand side. And then we'll divide both sides by 4.48 times 10 to the negative 2 to isolate x. When we do that, x equals 2.79 times 10 to the 3, and because when we set up the equation we defined x to be the grams of HCl, then this will have units of grams HCl,